Okay, we're almost there. Are you excited? I'm excited. Yeah, I know, right? I hope this goes well, because otherwise I look embarrassed in this silly outfit. Okay, great. So, my name is Marcel, and today I'm going to be teaching you how to wield types like a surgeon. Now, some haters out there say I'm not a real medical professional, that I am just a worryingly keen amateur. And to them I say, you'll never catch me. So, there's been a long history of mixing together medical and biological terminology into our software. We use terms like bugs and code rot, and even things like maturity, which implies that our software has a life of its own. It grows and matures and becomes something else. It has a cycle to itself. And in some ways they do, you know. Applications grow, then they get old and legacy, and then are reborn when someone attempts a big rewrite, and then it happens again. It's not uncommon to think about DNA in terms of programming either. The instructions are encoded into 4 different characters, and there's all kinds of stuff in there. There's go-to statements, there's commented out code, and you can't take out the commented out code in the DNA, because otherwise the go-to statements go wrong. Humans are the happiest code of all. Something we share similar with the medical profession is that we often have to diagnose problems in a very similar way that they do. So you're just given a grab bag of symptoms, like, oh, this broke, and it runs slow on my machine. So we go, okay, we've got a limited set of symptoms. We've got limited context, like what was the user actually doing? No idea. And we have real-life constraints, like you better fix this bug by lunch because we've got features to ship. We've got to move those tickets from left to right. And unlike real medical professionals, we don't get to use an MRI machine, which is a sad state of affairs. One thing that does differentiate us from the medical profession, though, is we build our patients as well as fix them. Does this make us mad, doctors? Yes. Next question. Incidentally, the processes and tools we use to build our software is also the tools we fix our software. The tools we use to fix our software. Come on, Marcel. Right, so let's take unit testing, for example. Unit testing is something we do as we write new code. It helps guide us as we create stuff. But at the same time, if we find a bug in some legacy code and we fix it, we often put a unit test in to make sure it doesn't happen again. But we're not going to be talking about unit testing today. We're going to be talking about static types. Static types! Static types offer a lot. They promise all kinds of things. They promise us confidence in our code, no longer will be making silly mistakes. They promise us faster refactoring, because now when we change something somewhere, our type checker will tell us where else we need to update stuff. Some static type systems promise no runtime errors. We should be able to write fewer test cases, because test cases like, oh, what happens if you put undefined in my function don't need to be tested anymore, because undefined can't get into my function. We have improved readability, because we now know what goes in and out, and that's actually written down somewhere rather than just a complete mystery. And ideally, we have better tooling support, because our editors are now able to infer from all this extra type information things like suggestions and other ways to help you. And this sounds amazing. But types have a cost. It's very, very easy to be bullish on types, but we need to be realistic about static types in JavaScript. It costs time to write types, and to write them well. It costs time to maintain those types as things change. And we don't even have to maintain our own types. We have to maintain the types of third parties too. And what happens when the library updates? Then you've got to make sure the types update. Editor tooling can be helpful, but can also be misleading and bloated and broken. We have to code defensively, sure. Your type system now says you have to check for undefined here, you have to check for undefined here, and this is great, but it is a chore, and it becomes very frustrating. Your build process can become more complicated as you now have to put this in. There's an opportunity cost to it, so you put static types in. This is at the cost of maybe doing more unit tests. There's also the concept of long-term risk and people. I want to talk about those last two in a bit more detail. So, risk. We have to think about the long-term risk about choices. Some type systems, you're pretty much locked in. If they're no longer cool in 2 years, you might be proper fucked. And this is something you really have to consider because you're committing to something that could be very, very hard to reverse. If it's a short project, that's not so bad. If it's a very long-term project, consider carefully. Even if you might not maintain it in 5 years' time, the person who does might know where you live. And the last is people. People are always tricky. It's important to recognize that adding static types in an application isn't just a chart where you look at the bugs in, bugs out, and hope it goes down. There's a real personal human cost because people have to learn how to do static typing. They have to deal with the frustrations. There's a lot of extra faff to consider. And people have a limited amount of spoons they can spend every day on frustrations. They've got to really understand and believe that all this extra effort they put up front will save them time in the future. It becomes important to recognize static types being made to feel junior because you don't know how to do the definitions properly for something incredibly dynamic can make people feel bad. And this is something that is overlooked when introducing a large amount of complexity through static types to a project. So we should treat types like a surgeon, by which I mean we should find the area we want to apply types to, we want to pick the correct tool, and we want to wiggle around in the patient, causing the least harm possible. We're going to focus on how static types can benefit existing apps while minimizing harm. Now, we're going to focus mostly on existing apps. Writing new apps in static types is much easier, and many of these tips will still apply. But the hard part is putting them into things that already exist. And we have the process, TM. We're going to look at our problem areas, and we're going to say, can static types help? And if they can, which tool would fit best? And once we've chosen a tool, how can we minimize the harm of applying static types? So let's ask the first question. How do we know if static types can help? Well, don't guess, be data-driven. Avoid low-hanging fruit and personal vendettas. It feels very good to just put // @flow at the top of a really simple file and go like, yes, I am amazing at code. I hope MIT is sending me my Chomsky degree in the mail. But it's actually often very useless to try and type things like a string when you're not putting it anywhere. And also avoid personal vendettas. You may have been burned by a legacy portion of the app a lot of times, but if it hasn't bugged out in a year, it may just be OK now and not worth spending all that time on. So how can we be data-driven? First, it's really important to have centralized logging. You've got to be able to really understand what's happening in the application. And once you have an eye on all the exceptions and errors and warnings, you can put them together and do some root cause analysis. And once you use the root cause analysis, you can find patterns to find problem areas in the application. OK, now we've got to figure out, can we put static types? Can we use static types to help a problem area? Well, is your problem area highly dynamic? Is it hard to reason about or filled with assumptions? Then you might want to apply static types. OK, so what are our tools in this slightly twisted operating theater? Well, these are the current big three in the world of static types. We've got TypeScript, the oldest offering from Microsoft, Flow from here at Facebook, and Reason, which is kind of like a weird mashup contribution of 20 years of OCaml, Facebook, and Bloomberg. TypeScript is probably the most popular one around nowadays. It has absolutely exceptional tooling as long as you use VS Code. I am unsure how good it is at other things, but I will be honest. Like Christopher was mentioning, if there's one thing from a system that you generally dislike that you really want in the thing you do like, I would want TypeScript tooling. It's great. The library definitions are good because it has a large community, and large community means you have lots of Stack Overflow posts, which are very important when you're trying to tackle difficult edge cases that can set you back many, many hours. On the downside, it's very verbose. You're going to be doing a ton of typing, and typing makes people sad. It's not type sound, and it never intends to be. What this means is if it says, I am a string, you can't actually be sure it's a string. It's just probably a string. I'm not shitting you on this. There are reasons why it does this, and they are very good, and they fill a niche in type safety with this approach. But it means there's a real ceiling to how good TypeScript can ever be, because there are certain tools and optimizations that will be impossible without type soundness. I kind of have this running joke that TypeScript is like signing an online petition of activism. It makes you feel like you're doing something, but it's kind of like, All right. So, and it's also too permissive. So without like putting loads of flags, config things in, it gives you way too much room to shoot yourself on the foot. I've seen projects launch where you're like, hey, we've typed everything, but you didn't use the strict null checks flag, and they push the boat out, and it all blows up. And you're locked in. So apparently, TypeScript is a superset of JavaScript. You could potentially go back to JavaScript. The reality is it's not actually a complete superset of JavaScript. And if you look at the compiled output of TypeScript, you want to go TypeScript, you're going to stay in TypeScript. We have Flow, which has rad type inference. It's completely type soundness. It can eject at any time. There's like a simple Babel plugin where you run once and it strips all the flow types. And you're back to the safe community herd of JavaScript. But the tooling is frankly embarrassing. The VS Code plugin hasn't been updated in over a month. The hover over never works. The CLI stuff works great, but it's wrong too often for people to get frustrated. There's a smaller community, so you have less help, and there's a higher chance of frustration. There's lots of little things like, oh, the service won't die properly. Oh, it got stuck here. Oh, like flow bin updated. Now this won't work on CI. Yeah. And there's Reason, which is like the new kid on the block. It has type inference like, whoa. It's amazing how much you don't have to write. The performance output is amazing, and it's the complete package, which I'll talk about in a second. However, it is still very new. You will write bindings, and bindings are the interface between your JavaScript libraries and that you want to use within Reason. And the injection story is okay. I think for a while, the reason people had this idea that all Reason compiled output should be superhuman readable, but I think they sort of strayed from that over time under the auspice of performance. But what you mean, and by the complete package, I mean, when you use Reason, you don't have to use any of these things, so they come completely baked into the language. And things like Prettier were just like straight ripped from the Reason formatter. The Ramda stuff is built into the language. ESLint and Flow is all just packaged in. It's amazing, because it means when you add it in, your build process remains fairly simple. OK, so now we've got our tools. How can we minimize costs? Well, this is kind of like a difficult question to answer with concrete points. But we'll try and follow these core tenets. So you should try and keep the type definitions minimal. As many as you need, but not anymore, because obviously someone has to maintain them. We should create types of attention to detail, because if you type something wrong, obviously we're going to cause a lot of damage over the long run. We should centralize the namespace. Don't put your types all over the shop. Try and put them in one place and namespace them if you can to avoid clashes, because you want the types to be discoverable. You don't want them to be written in several places by different people, where they have to be hunted for, and then people need to figure out, OK, so should this be this, or should we do this? One flat file is usually a good place to start for nearly every project. Don't be too clever. I've seen attempts to create new types and other types using pick and merge and all these other kind of clever functional tools, but that just makes it very hard to reason about. Be explicit with your types. Longer is better. Just make it easy to understand. And automate if you can. Writing types sucks, and if you don't have to, don't. All right. The operating room is prepped. Let's look at 4 patients and see if we can apply the process to those problems. Now, you're all going to ask me one question on the pub, and I'm going to answer it now, so I don't have to do it then. My font is Dank Mono. My theme is Dracula. All right. Dank.sh. Buy it today. I believe it's still £40, but it's well worth it. Phil, send me a split of revenue, please. All right. Patient 1. Doctor, my form is driving me crazy. It's like, oh, wow, OK. A website with a form, how original. Cool. So the symptoms of this, the customer complaint, the form has, a first name and a last name, and a way to change your telephone number. One customer complains there's a missing first name. You look in the logs, and there's an exception that you cannot call to uppercase undefined, and you have a 500 from a server submit. Like, all right, well, hypothesis is straight away. We probably make assumptions about the shape of the side effects. The data comes in and data comes out. But we're going to apply the process. So we're going to look at this and say, can static types help? Which tool would fit best? And can we minimize the code? Can we minimize the code? Can we minimize the costs? Let's check the code. So, oh, by the way, I have a rule against doing live demos, so I'm doing 4. All right. So this is a very classical form, we have a little greeting here that says, hey, hello, user first name, and then user to uppercase last name, so it's capitalized because you want that pow and make them feel scared when they fill in a telephone. You have a label for the telephone field, which has a little onChange, so we can update the state, and a submit button. And we can see here that when we update the state, we simply update it here in the constructor-defined string. So I'm sure you're all very good engineers, and you've spotted a couple of bugs straight away, or where they might come in. I mean, fist name is a good one. But as you can see, by default, this isn't something that gets caught. This is a basic Create React app version 2.0. Woo! But you know, I just wrote this bollocks, and I was like, yeah, this is fine. Which is, I put in some intentional mistakes, I hope, but we know it's wrong. It has problems. So where do we actually get the types from? Because we've now decided, like, yes, we made assumptions about the types, and things aren't as clear as they could be, so static types can help. So the static types, ooh, mouse, no. You could just kind of guess and refine the types, right? Maybe if you're working on some really large, evil enterprise, and there's some REST endpoint that you don't communicate with and there's no documentation for, you'll just have to like learn what the actual response types are over time. I'm sorry. You might have some documentation, which is okay, but for every large organization I've consulted for, it almost always is out of date in some way, or even just plain incorrect. But if you have a GraphQL schema, bingo, because now you have up-to-date, correct documentation of what you're definitely going to get. So let's be kind to ourselves and assume we have a GraphQL endpoint. And let's add those types. And what would that look like? What would happen? Well, if you look at this version with types, and the props are described at the top, we have, oh, wow, yeah, you can see good lens, and you can see that 3 days ago, I finally finished this presentation with this amazing commit message of yes. Right, so we have a user. It has a first name, a last name, which turns out to be optional. So, oh, wow, that brings that bug into focus. And telephone should be a number. So we can quickly see that, yes, this user prof. What did I do wrong? This one should be, I'm going to blame flow being temperamental, which, again, oh, yeah, here we go. I know I did wrong. So, props. Beep, beep, beep. I don't do live demos for a reason. OK, cool. Right. So we can see we've got some errors here, and they're nicely printed and whatever. We say we should be using event. This user, it's kind of like, you don't know it's going to be there. Hold on. Yeah, so you can see the simple stuff like, hey, this might be undefined. You should check for the user first. Hey, this is not actually a key on the object, and your telephone number should be a string. So it turns out after some investigation that the server expects it to be a number, but we had an international custom put plus at the front, so they couldn't do automatic type coercion, and that was the source of our bugs. So you go like, OK, types can really help me out here. We can now see exactly what went wrong. We can fix these bugs. They won't happen again. And you're pretty pleased with yourself, but not so quick, because the costs are still pretty high. Will the API change? And if it does change, who's going to maintain it? And not even considering the API changes, what about syntax updates? Flow syntax changes over time. And here we've chosen Flow as our tool because Reason would have been a rewrite. TypeScript would have been equally good. We're trying to minimize harm. So you think, can we do better? Well, we already have the GraphQL types. Is there something we could do with that? So you do a bit of searching, and you go, OK, we can use ReasonML with PPX, which gives you some cool auto-generated checking on your code based on the schema you have, and that gets pulled from the GraphQL point intermittently, so you have a bit of safety on that. But you think, like, oh, man, I have to put a whole new tech into my stack, and I have to rewrite my code in ReasonML. And then look at Apollo CodeGen, and it will inspect your queries and your schema and generate you TypeScript or Flow types automatically. And you can run it often as you want. You can then reuse those types around your software. If you're like, that sounds like a much better idea, because that has a lower cost. So what would that look like? Well, it is, charmingly, surprisingly easy. So now, if we look at our, I'm going to close this boy. Look at our package JSON. Woo. We have a schema, a get schema, which is just using the GraphQL CLI to, well, get the schema, and it dumps in a little file. And then we use Apollo CodeGen and say, like, OK, we want to go to our schema file. We want to make flows, make flow types. We want to pass through some scalars. We want to make them read-only types, add some type names, and put it out in the flat file. And now, if we actually look at what it generates in flow typed, bump, bump, you can see it auto-generates us amazing, ready to go, expertly read-only types. And we can run this as often as we want. You can put it as part of your CI process. Now you don't have to maintain the types. And because this is flow typed, it's already in the global space. So instead of having to go like propsy write yourself, you would just do get user. Oh yeah, and you get all the good stuff for free. Hooray! All right, so we've done the process. We looked, can static types help? Yes, they could. Did we figure out which tool fits best? Well, we decided on TypeScript or Flow because these were the least intrusive. If you already have a TypeScript project, go for it. I chose Flow here because create React up is very easy to put Flow into very easily. And can we minimize the cost? Yes, we made sure we don't have to maintain the types. Now the only cost is that our process is slightly more complex, but it's hopefully something you have to think about very, very rarely. Patient 2, doctor, the bug trickle won't stop. And you're like, huh? What are you talking about? So this team has a consistent amount of bugs happening every week. And all the code is unit tested. I think it should be 0. Why do they keep getting bugs through? And no matter what they try, the new bug new count is not decreasing because I put new bug in twice. So you think, is this something I can really help with? Well, let's have a look at our problem area cheat sheet. Is the code highly dynamic? Is it hard to reason about? Or is it filled with assumptions? So let's check some more code. Ooh. Cool. So we have a very simple menu, which has, it has 3 buttons in a menu. We have a home and a profile, and if you're an admin, you get to see a control panel. And their bug is that everyone gets to see the control panel. And you think, how on earth can this be wrong? It's so simple. So, you check the unit test for this thing. And, like, OK, so you've got a little enzyme stuff going on. You find that if you put the admin in, you find the button. And if you don't have the admin, you don't have the button. How is it broken? Well, my friend, you've quickly noticed that is admin is either a string of no or yes, because this was written in the Victorian era and everyone uses old Oracle databases. And no Booleans exist. So, you curse yourself. The code was simple. It was unit tested. You thought it was going to be great. But if only you had used types, you would have known that this isn't kosher. Alas, because you made an assumption. So, static types can help. Again, here I would prescribe Flow or TypeScript because it can just easily slip into your application without having to do any major replacements. And this isn't something that taxes any type system. Cool. OK. Let's go back to the slides. So we had the hypothesis, which is taking shortcuts in unit tests. Yes, now you'll have to write the whole object, which is the cost, but you'll also be testing your code more correctly. Often you find that people will, in their head, say, like, I know how this code works. I'm just going to put in like the few variables I need to do to make the test go. But it isn't always representative of the final functionality. Patient 3, doctor, my form hurts too. Oh, well. Let's look at the symptoms. Customer complains of missing data in the form, errors in submitting. I might be going, aha, another one. Not so fast. I told it to be data-driven. So have centralized logging, look in the logs, look at the metrics, do some root cause analysis, and find patterns. So after checking the logs, what do we find? Timeouts. Can types help? No. It's just some third-party thing you're drawing stuff from. Go send them a snotty email. OK, the final patient. Doctor, your corporate purchasing app is unreliable. Unacceptable. Everyone knows All shadowy steampunk organizations live and die by their purchasing and expenses system. Just ask Gru. So, what are the symptoms? Well, you can't add items to the wish list reliably. Bypass codes aren't working, and it crashes when Arch Minion uses it. For this to make sense, we'll have to look over the intent and functionality of the purchasing app. So let's look at Asgard purchasing. There is a shopping list and a wish list. Doctors can't add anything to the shopping list. Staff can add anything to the wish list. Up to 3 things can be on the wish list, because I'm not made of money. A code will allow any addition to the wish list, and if an item is cake, it can get added to the wish list without checks, because I'm not a monster. With business logic this succinct and totally not fragile, I can't see how any bugs could slip into this application. So, what does it look like in JavaScript? Dang. All right, so we have a component, classical style. It has some state of the current item that they're typing in, a shopping list, and a wish list. We render everything in the wish list and the shopping list. I'm gonna boop boop this way. Everything in the wish list and the shopping list. And when we click an add, we go up to this one up here, and we check if you're a doctor. And if you're a doctor, you can add stuff all the time. Otherwise, if the wish list length is currently less than 3, or they use the bypass code, the code is doctor at its best. Or the current item is cake, you get to add the wish list. Now, you might be thinking like, oh wow, what if you start to get more roles and you pass like 8 different kinds of things to profs? How big will this logic get? Will it become very confusing? This technically will work. It's a good code. Can starter types really help you deal with a torrent of business logic? And the answer is yes. Types don't just catch mistakes. Good types can also offer clarity, because it lets you express your intent more clearly, succinctly, and in ways that can't go wrong. So, to do that, though, we'll probably need to use a language that lets us do more with types than just check strings. And for that, we're going to use this cool hipster point language called ReasonML. So, the end is very similar. We have a div with a wish list and a shopping list. This is just a mapping of the stuff currently in that state. We have an input where we put in the item we currently want, and we have an on-click event, which is add. So you can see here, like, rather than doing something to do with set state, we have a send, and send is very similar to dispatch. Now, dispatch makes you think of Redux, and unlike regular React, Reason React comes with components that have Redux essentially built in, a one-way data flow. From there, we can actually do pattern matching on all the different bits and pieces. So here what I've done is I've gotten the action, which is the add. We also have the update for the current item we're piping. The role of the person coming in. And unlike JavaScript, we don't have to do emulation of enums. We can have real variants. So it can be a doctor or a minion, but it isn't a string check. It's a real thing that can also hold values, which is very, very important and a good way of reading by your code. You don't have to always just do Boolean checks. You can now describe things with the way they actually are, which is much easier to read. And then you come to this block of description. So if you're a doctor, you can add things whenever you want. If you are a minion and the wish list isn't full, or you're a minion and use the code doctor's best, so you can see in the 4th row we have the bypass stuff, or it's cake, you get to update your wish list. So putting it in this way means that you can see it's much more expandable, it has room to grow, because you can now have any number of roles very easily and describe them all in one block. The intent of the application is much clearer. So, home stretch. Good types and just exceptions. Good types can offer clarity. The outcome here is that you have greater certainty in our code because everything is 100% type-checked all the time. Our business logic is more clear, and we have obvious view of how we will expand this in the future rather than having more and more nested if statements. Downsides of doing this and getting a reason component and putting it in your react.js project. Context switching, you now have to think about things twice. You have this additional technology to consider. But the big one is the type parity. If you have Flow or TypeScript in your current React project and you want to put reason in it. Remember, that component had a prop of the role you're going to pass in. So you've got to say, on the outside, we're going to pass you a thing called role, and the inside, we've got all the stuff about role. You've got types defined in 2 places, and that super sucks. When I rule, I want there to be some sort of magical system that looks at a reason component, figures out the exact types of everything inside it, and just offers it up to the outside world, which would be a nice dream. Oh, wait, it totally exists, and it's called gentype, and it's amazing. This is somewhat beta, but we'll quickly go back to the example and show you that now when you want to put this component into a JavaScript, you don't have to write your own bindings at all. You just stick the words gentype on top, or add gentype even. Ooh, I never do live demos. Why do I do? I make poor choices in life. And what happens then is you get this list of types pre-made for you that describe the component you just created, which you can then just dump straight into your actual JavaScript in the interop group here, and it'll do all the type checking for you. So you can see you've got everything that you might desire, including things like minions. So now if you try and use your reason React component and don't give it the correct props, it will shout at you in flow, which is pretty damn cool. Now it's much easier to start rewriting stuff in Reason and put in a React application. We've really minimized the cost of using our dope-ass hipster language. So, the future. I think what will happen over time is we will continue to try and derive more value and minimize the cost of using static types in the JavaScript wasteland. The reality is we'll probably be focusing more on minimizing costs because that's where the best gains are to be made now. I think it's also important to recognize that static types are something that is in response to the complexity of front-end development. One thing I'm keen on saying, and gets me the most booze on Twitter, is that front-end isn't moving fast enough. A lot of people like this idea that web developers are doing all the stuff because they're bored, because I guess the web is this wonderland development, and we have all this free time to tackle just hobby projects. But that's not true. We have this deluge of difficulties because we're trying to build complex, critical applications with a bunch of document primitives in a browser. People aren't going to stop using the web. The web will continue to be important. It's an open platform for everyone. But it is also becoming more and more critical. It is our responsibility as the kind of people who push new technology, push new ideas, to make decisions that accelerate this process to the point where mediocre software isn't swallowing the world and starting to cause real harm to real people. So, conclusions. Types will ever be more important. Keep a strict tab on costs when you make them. Focus pathologically on people, because they're the ones who'll be writing it. They're the ones who're maintaining it. And also understand the feelings and frustrations. A very wise old man once told me, treat every person you mentor with the idea that they might have zero knowledge, but a capacity for infinite intelligence. And never let mediocrity swallow you. We can always do better. If you would like to do better at a place I'm currently consulting, that's super cool, and we work with some Elixir, it's a little bit of Reason soon, and JavaScript that's kind of getting there, check us out at Nested. All right, I've been Marcel Cutts. Thank you.